We haven't got into paralleling, and we're going to do that here, just days get short. When you're paralleling generators, again, what controls KW? What's KW all about? Work. Work. And who's doing the work?
Your building.
No. The engine, the prime mover. So KW is all about the prime mover. It's doing the work. Now, what about K-bars, amps? What's controlling that?
Alternator.
Alternator, but more specifically?
The magnetic field.
The voltage regulator is controlling that. The governor to the engine is controlling the work, right? The KW. The voltage regulator is to the alternator what the governor is to the engine, okay? The regulator is controlling, in a paralleling application, the amps, the K-bars, okay? So when you're paralleling generators and you have no K-bars, you don't know if the regulators are going to play nice, okay? They can work just fine. But the minute the K-bars start to kick in, if you don't have the CT polarity proper, if you don't have the CT on the right phase, things start to get ugly, okay? So whenever you're paralleling generators, you should go through a commissioning process. That commissioning process should include K-bars so that you're not only testing the prime mover and KW and load sharing, you're also testing how the generator voltage regulators are sharing the K-bars of what's going to be the load. So instead of using the building, you're bringing your own in. Now, to the point we were saying earlier, is there such thing as a pure inductive device in a building that would create 200 amps? That was the conversation, right? And be doing nothing. Well, this is an example of the equipment, but you're never going to have something like this in your building running. For what reason? It does nothing. It doesn't even put out hardly any heat.
But wait. I remember when I was looking on the gauge over there on the screen, you had a lot of K-bars, but we had a little bit of watts. We had some watts.
2.
But we still had some watts because this was not pure.
I can tell you, I can tell you those watts are minimal, and it's probably from some other device. But at any rate, for what you get out of it, it's not something you're going to buy and install. So, in order, and here's the other thing, you want to say you want a load bank, you're 2 megawatt. What does the alternator come from the factory rated at what power factor? 0.8. So we went through the math on how to be able to do kilowatt load banking with Unity, but are we being able to get full amps out of the alternator? Couldn't, right? Because of the Unity power factor, and we'd overload it. So between the resistive and the reactive, now you can create a actual full load test on the prime mover and the alternator with the amp at the same time. Bringing it all together. So that's why there's reactive load banks. So, you know, how many people ask for a reactive load bank? Nobody. I can tell you, if you want me to do a reactive load bank, I'm going to do cartwheels down the parking lot, because that's good money. Okay? You charge for that. These things are expensive. Okay? So, you know, I love doing reactive load banking, but the reality of it is most people on an annual service, you really don't need reactive load banking. You use this equipment for commissioning and testing. That's really why you need it. Okay? Does that all make sense?
Yep.
Clear as mud?
Yep.
All right, let's go in the classroom and let's get into the bolts and nuts of